today's not real specific about, well, now that I'm looking at it, yeah, maybe it is a little bit. We're going to start off pretty general, then we'll get a little bit more specific. I was thinking of a different section we're going to do fairly soon. I think, tomorrow. Yeah, tomorrow. The next section is we're going to get a little bit more specific about congruent figures, okay? We're going to really talk a lot about, oops, I forgot to change this. Always forget to change it. It depends on if we finish today or not. I plan to finish it. So we eventually, which is tomorrow, we're going to do things called congruent what? What do you think this is? Triangles, okay? But right now we're kind of going to be a little bit more general and talking about congruent figures. But a big part of geometry is talking about congruent triangles. So this is kind of going to lead us up to talking about congruent triangles. And if you talk to anybody that's taken a geometry course, and if you ask them what's the one thing that you remember from geometry, this could possibly be one of those things that people would say. First thing they would probably say is proofs. Oh, I remember proofs from geometry. I hated them. See, you won't say that because we're not doing proofs in here. All right, so be thankful for that. But we are going to talk about congruent triangles, but not specifically today. We're going to talk about congruent figures. We've already used that word congruent. Do you remember the little symbol for congruent? What is that symbol? It's an equal sign with a what? Little squiggly on top. Somebody said in one of my classes, oh, that means approximately. Does it mean approximately? No, not with an equal sign underneath of it. Okay, this means what? Congruent. Okay, we use that word a lot. I said before, like if I had two line segments and they were equal to each other, the measure was equal to each other, I could say that those line segments were equal, or I could say those line segments were congruent. I personally don't have a problem one way or the other. But when you talk about what we're going to talk about today, we are only going to say congruent. We are not going to say equal. Everybody hear me on that? All right, this is where I draw the line. All right, some teachers would always use the word congruent for, even if I said this angle A is congruent to angle B. I'm okay if you just said angle A is equal to angle B, but a lot of teachers would be very strict saying that angle A is congruent to angle B. But what we're doing today, I feel very strongly that we use the word congruent. Everybody good with that? All right, so let's talk about what a congruent figure is. Well, two things must have to be true about them if it's a congruent figure. Okay, the first thing, they must have the same size. So the same size. They got to be exactly the same size. And secondly, they have to have the same, the same shape. All right? So they got to have the same size. They got to have the same shape. So let's just give you a quick little example. I'll pick a polygon. Does anybody have a favorite polygon? Not super big. Dodecagon? Okay, 12 sides. All right, there's a dodecagon. All right, everybody see that figure right there? Now, it's not congruent to anything just yet, okay? But what can I do on my computer program to make it congruent? Have the same size and the same shape? Copy and paste, that's right. So that's what I'm going to do. I'm going to copy and paste, put it right there, and that's what I did. Control-C, Control-V, and I've got two what? Congruent figures, okay? And let's make one a different color just for fun. All right, so those figures right there are congruent figures. That means they have the same what? Same size and same shape. So that means I should be able to pick one up and do what to it? Put it right on top of the other one, and they should be exactly the same. Is that true here? Yeah, right there. Everybody good with that? What if I did this, though? Whoops. What if I did this? I'm going to hit the shift button. Do you know what the shift button does when you grab a corner? It keeps it the same shape, but it changes the what? The size. So, are these two congruent to each other? No, they have the same exact shape, right? Same sides, right? Same number of sides, okay? In fact, they're all equilateral or equiangular. All the sides or all the angles, I'm sorry, are exactly the same in both of them, but I changed the size of it. Agreed? So are they congruent? No. All right. Are they congruent now? Yeah. All right. What if I did this? Like that. Now are they congruent? No, they're not congruent because look, some of the angles have changed. Would you agree with that? Right? All the angles, it's definitely a different shape. If I took it and I picked it up, put it right on top, maybe a couple of those, look, a couple of those sides are the same. Like that one right there on the right, you see that one? And then that one on the left, they're the same. But some of the other ones changed definitely, didn't they? Look at the top. The lengths definitely changed. So are they congruent? No, they're not congruent. All right, everybody good so far? Yeah. Let's talk about circles. So let's draw a circle. Let's make it white. It doesn't matter. Yeah, let's make it white. All right, now I'm going to copy and paste again. Control, what are the keyboard shortcuts again? Control what for copy? Control for copy? C. Control C. And then what's paste? Is it P? It's V. Why isn't it P? Because Control P does what normally? What? Print. That's right. Control P usually does print. Okay? So anyway, why do they pick V? Just some random letter, do you think? Where is C and V on the keyboard? They're next to each other. That's right. So Control C, what? Control V, right? I'm here to teach you more than just geometry. All right. So what do I got right here? I got two circles. So are they congruent to each other? How do I know if they're congruent to each other? Well, if I stick one right on top of the other one, it's exactly the same, isn't it? So what's true about those two circles? They are what? Congruent to each other. Well, it's a good question. Is there a what? I'm going to show you something right here. Tell you what, let me, I'm going to put that point in the middle, and I'm going to get this point in the middle as well. What is that point that I just put in the middle of these two? It's not just a dot. It's what do you think it is? It's the center of the circle. That's right. Okay, it's the center of the circle. So check this out. If I go from the center, we've talked about this before, right? This is not new. If I go from the center to any point on the circle, what do I call that thing right there? The radius. Call it R for radius. And then, watch this. If I go from the center of the circle, again, I don't have to go to like the same exact angle. I could go down here. It doesn't matter where. I could go like this if I wanted to. It doesn't make any difference. Okay, so if I went to there, this would also be the what? Now, if I said that these circles were congruent to each other, what do you think might be true about the radius of both of them? They're both exactly the same. They're both equal to each other. Exactly. That's a R. It's supposed to be an R for radius. My R just looked weird. My writing with this new tablet, I told you I got a new tablet, right? I still got to get used to it. It's acting really strange. I don't think it's acting strange. It's just, I don't know. I thought my writing would be better with this new tablet, but it's actually worse. So I just got to get used to it. Someone get the door, please. All right, so what if I said the radius of this circle was 5 inches? Okay? And I said that these triangles are these, not triangles, these circles are congruent to each other. So what must the radius of this be? It must be 5 inches as well. Okay? So, how can you tell if the circles are congruent to each other? They have the what? The same radius. Exactly right. Not that big of a deal. All right, enough of that. Let's move on. Let's go to triangles now. I said tomorrow we're going to deal with triangles a lot more specifically, but we're going to kind of mention triangles right now. So let me just draw, I'll tell you what, I got some triangles. I haven't used these. Look at that. See all these triangles I drew over here? Let's grab one. Which one do you like the best? This bottom one? Okay. All right. So let's just make it a little bit larger. There we go. All right. So there's a triangle here. I'm going to copy and I'm going to paste. And I'm going to put that triangle right here. Everybody with me? This is kind of foundational stuff, okay? Because without what we're doing right now, anytime we talk about congruent triangles, you're not going to know what we're doing. So today is important. It's just like we're just establishing a standard, a little baseline here, all right? Now, if I said that these triangles were congruent, now, do you agree that they are congruent because I copied and pasted, right? Or I could take that, if I put it right on top of it, see how they're exactly the same? Okay. Now, what if I did this? Are they still congruent? Sure, because I could still like turn it around, put it right on top of it. Everything still matches up. Would you agree? And that's the key to that. Everything matches up. That means that line segment AB, what do you think? That's right, is equal or congruent to DE. Everybody see that? Let's mark it. All right, so this one and this one. If they're congruent to each other, I tell you what, let's write it down. How would I name this? Name this triangle what? ABC? Yeah. You could name it a bunch of different ways, but ABC is kind of easy. It's congruent to, so let's put the equal with a little squiggle on top, is congruent to triangle. Now, I got to be very careful. When I mark triangles congruent to each other, you got to put it in the right order, right? The things have to match up. The vertices have to match up because that's the way they want you to do it. Nope. What it does, it allows you to know which things actually are equal to each other just by looking at your congruent statement, okay? This is called a congruent statement. So even if I didn't have my picture, I would know that angle A, talk to me, angle A would equal what from over here? Angle D. So what goes first? D. So if I called that one ABC, I got to call this one a certain thing. Call it D, then what? E. Now, because B is next, right? See the B and the E match up? And now the C and the what match up? F match up, okay? So you must, if you call one thing, the other one has to match up, okay? This is the first time I'm going to say it, but we're going to say it a whole bunch of times later on, okay? The corresponding parts, do you hear what I just said? The corresponding parts have to match up, or well, if they're corresponding, they're going to match up anyway, but they have to be equal to each other, okay? The corresponding parts. What parts do a triangle have? It's got angles and it's got what? Sides, okay? They are line segments, that is true, but we call them the side of the triangle. Everybody with me? So that means all the angles have to match up and all the sides have to match up. We got it? So that means the corresponding parts have to be equal or congruent to each other. Let's write that down because I think that's so important. You don't know how many times we're going to say that. It's the first time you've heard it, but we're going to talk about it a whole lot, all right? So the corresponding, I'll just put CORR, is that all right? The corresponding parts are congruent. I'll just say that. Okay? So if you have congruent triangles, the corresponding parts are also going to be congruent to each other or equal to each other. So that means that AB is also going to equal what? DE. Let's do the other sides. What about AC? Let's put 2 tick marks for that. What's going to have 2 tick marks over here? DF. Okay? And then what? BC must equal what? EF. Everybody with me on that? So if I took this, picked it up, put it right on here, which ones match up? The AB and the DE match up. The AC and the DF match up. The BC and the EF match up. And they are going to be equal to each other if those triangles are congruent. Yes? Okay. There's something else. What other part? Okay, we said parts. How many parts are there to a triangle? The sides and the angles. The angles. Okay? So let's do that. So let's call this angle A. We'll put 1 arc for that. So over here, what's equal to angle A? Angle D. What's equal to angle B? We'll give that 2. The 2 just means the ones with 2 are equal, the ones with 3 are equal, the ones with 1 are equal. Okay? And same thing with the arcs. The angles with one arc are equal to each other. The angles with what? Two arcs are equal to each other. And the angles with three arcs are equal to each other. Okay? So, if those triangles are congruent, you know all that stuff must be true. Okay? So what if I just had the congruent statement and I didn't have the picture? What if I just had this without the picture? You should be able to tell me what parts are equal to each other. Let's list them. Let's do the angles first. That's easier. So angle A, just by looking at this, you should be able to tell me, without seeing the picture at all, you should be able to tell me what angle in this triangle is equal to angle A in this triangle. What would that be? Angle D. What's that? Like right here, you could. Okay, a lot of geometry teachers would require you to put the squiggly, make it congruent. I'm fine if you just say the angles. I'm fine if you say the angles are equal and the sides are equal. But when it comes to triangles, never say the triangles are equal to each other. Always say the triangles are congruent to each other, okay? There is a slight difference between saying this angle is equal to this one or congruent to it. I'm not going to worry too much about that. Let's list the other things that are equal. What else is equal? Angle B must equal what? Angle E. And then what else? Angle C must equal angle F. Everybody see that? Just from this congruent statement. We call this a congruent statement. Just from that, you should know which ones are equal. That's why it's important to put it in the correct order. Because if you don't put it in the correct order, you have no idea by looking at the statement which angle is equal to what. Okay? Do you have a question? You could do either way. Okay? Again, most geometry teachers probably would prefer you to say congruent. Okay? But I'm a little bit easier with that. I'm not as strict with that, I'll say. You could say equal or congruent. I don't care. All right? Again, most geometry teachers would say congruent, though. All right, what about the line segments? Let's take a look at this. The sides of the triangles. So how do I know what sides are in my triangle? Well, I got the first two. That's side AB, correct? So I could say that AB. Now, here's a big difference. Let me just explain to you quickly the difference between putting an equals and a congruent. If I just said angle A and angle D, you should put congruent, okay? If I said this, if I said M angle A, what does that M mean? The measure of the angle. Then I could put equal, okay? Because when I say the measure of the angle, I'm talking about a number. I'm saying it could be 30 degrees, it could be 60 degrees, it could be 100 degrees, okay? So I could put equals when I'm dealing with numbers, okay? So if I did this, then I could say equals, all right? Same thing with this. If I said line segment AB is equal, or I should say what? Congruent to what? DE. How do you know that? Because look, it's the first one and the second one, and that's the first one and the second one. So they got to be equal to each other, or congruent to each other. You with me? Give me some other sides of triangle ABC. BC. So, line segment BC must be congruent to what? Over here. EF. Everybody see it? It's not hard to see. BC is just in order, right? The middle one and the last one. Middle one, last one. Yeah? What's the third side then? We did AB, we did BC. AC would be the next one. All right? So, AC would be congruent to DF. You getting the hang of it? Yeah, CAAC, same thing, but I don't have to do it twice because it means the same exact thing, all right? But that's it. That's my only combinations, okay? I only have three sides to a triangle. Those are my three sides. You got it? And if you looked at this, it would work, wouldn't it? It would all match up. So that's the nice thing about this congruent statement. The congruent statement, it's very, very important that you put the stuff in the right order. Because if you don't put it in the right order, you can't look at it and say, oh, angle A is equal to angle D. You with me on that? So it's got to be in the right order. So keep that in mind. All right. Looks like we might be doing, well, let's see. So that's all the stuff we have to teach. Now we're just going to do some examples, all right? And I got like 5 minutes left, and I don't think I'm going to be able to do them all. What did I have tomorrow? New lesson. Shoot, we're going to be behind. Let me draw this thing for you. It's in the book. Go this way. Let's do this. Oh, I forgot what I used. No, I think I used... No, that's not what I wanted. Hold on. I know I have a thing up here that'll switch it. I don't think it's that. No. Ah, shoot. 90? No, that's not what I wanted. Let's see. How many degrees is this? I really shouldn't be this picky, but I'm being stupid. I'm not gonna be so picky. I'm just gonna draw it. Tell me if that looks pretty close. Yeah, not exactly. Oh, my perfectionism is making this worse. Let's do this. All right, it doesn't have to be that perfect, for goodness sakes. Okay, stop. What I'm going to do now is go from here to here, and then from here to here. All right, that's good enough. It's not perfect, and it does bother me that it's not perfect, but I'm going to keep it just the way it is because of the time. All right, and let's put some letters in here. This might be the last thing we can do today. V, W, X, and Y. I think this example they talk about being the trusses of a building. You know what the trusses are? So if you go up in your attic, okay, if you have a house, you go up in the attic and you see all these wood beams going all over the place. Okay, those are trusses. Keep everything stable. And that's what this is. So it says if triangle UVW is congruent to triangle YXW. All right, they give you a lot of information when they give you that thing. It just says list the corresponding parts. All right. Now, what I would do sometimes, I'm just going to draw this by hand. UVW, where is that? UVW. So just for the sake of time, I'm going to do this really sloppily. There's UVW. Everybody see that? And then the other one is YXW. YXW. So this is going to be, there's the XY, there's the WX, and there's, all right, very ugly, very sloppy, but it's good enough for us. All right, so do you see what I did? I just took this triangle right here. I made it look right there, and then this one. I probably could have just kept them in there. But sometimes it is good to draw them separately away from your big picture because a lot of these lines really don't do anything for us, all right? So that's what I'm talking about. These are supposed to be congruent. It looks horrible. Sorry about that, but you still get the idea, don't you? So it says list all the corresponding parts. So what match up with each other? Okay, UVW. So that means angle U equals what? Let's do the angles first. Equals are congruent to angle what? So angle U is going to equal what? Just look at your congruent statement. Nobody's talking to me. Angle Y, that's right. So these two are going to equal each other. Or I could put that right there and right there. Everybody see that? All right, and you know because this is a congruent statement, the first one and the first one have to be the same. All right, what are the other angles that are equal to each other? Angle what? Angle V and angle X. Good. All right, so V and X, these two up here. So I'll put 2 arcs here, 2 arcs here. Definitely made that too small, didn't I? And then, of course, W and W, right, they're going to be the same. This one right here and this one right here. Do you see if I pick one up and put it on the other, it doesn't fit exactly? I'd have to like flip it over and then they would fit exactly. All right, so sometimes you have to think about that. And of course, angle W is congruent to angle W. What about the sides? So UV, just look up here. UV, if I put a tick mark right there, would equal what? YX. YX is right there. So those two would match up. See that? So this one and this one would match up. All right, what else we got? Let's do VW. So VW here would equal what? XW. So VW would equal XW. This one right here. So those two would equal each other. And then, of course, the third one, that's the only thing left, right? So UW, yep, UW equals YW. So that's just asking you to mix them up. Now what they're eventually going to do, I think I've given you enough, okay? What they're eventually going to do, they're going to say, like, angle U is equal to 30 degrees. So what's angle Y? 30 degrees, okay? You with me on that? And then they might say, like, angle W is equal to 3x plus 2, right? And then this might be 5x minus 7. So what do? If they're equal to each other, you set them equal, solve for x, and all that kind of stuff. All right, so I didn't hit all the examples. What I would suggest to you is to look at the examples, or if you really can't do that, what can you do on YouTube? Go to last year's, right? Go to last year's honors geometry class, look for section 4.2, and there'll be the continuation. I've got it all on there. So if you really need to do that, make sure you do that. So I gave you a lesson plan yesterday, right? I forget what it is off the top of my head. It's 1 to 14. There it is. So 1 to 14 is your homework tonight, okay? See ya. It's just 1 to 14. You got your lesson plan from yesterday, right? Just look at it. Oh, from the book? Yeah, you can do that. That's fine.